but we also read graphs from left to right, okay? How about the second one? What's going on that second one, Brian? What are we thinking? Why? Why, Brian? It's going down? From where, Brian? How do you read? From left to right, yeah. It's very important, extremely important for us to realize, yes, it's going down, but from left to right. Because if we don't realize that, well, from right to left, I'm actually going up. I'm actually going up. And over here, from right to left, I'm actually going down. So it truly matters for us to understand, oh, it's from left to right. That's the way I read. That's the way I do graphs too. How about the number 3? What you thinking about? What do we get for our equation? I want to hear from Brandon. What do we get for our equation? Yeah. You didn't do it? Is that because your calculator number 2 didn't work?
I didn't do that, but I did.
How about number 3? What did you get for number 3? I want to hear from Jessica. -16? What? Negative 1,260? 60.5? 61.61? Oh, 61, okay. 0.5x, yeah. 12,413. Okay, 13. Awesome. That was my equation. Excellent. Good job. FYI, the steps are going to remain in here, and today we are going to have a lot of practice. Just to make it very clear, if you bring your calculator to calculate, if you bring your calculator to class and it's not charged, it's like you didn't bring your calculator, okay? I've been saying it, but just make sure that if you're gonna bring it, it's charged. If not, it doesn't count. It can help you. It definitely can help me if it's that. Now, what was my correlation coefficient on that one? I want to hear from, yeah, go for it. No, what was it?
-0.
Negative 0, yeah, point.
997.
997. Here, I definitely didn't ask you explicitly, but connecting on yesterday. And everybody, we're all looking at this number line now. Make sure you're looking at this number line now. Let me erase this so you can clearly see it. This is one of the things we were working with yesterday, from -1 all the way to 1. If I was to graph this, Noe, negative 0.997, around where would that be located? On the left side or on the right side? On the left side. Would it be pretty close to 1 or like kind of away from 1?
Really close to 1.
Okay. Would that be strong or weak then? Would that be positive or negative?
Negative.
This is why, and I wish I would have planned ahead for this one, but this is why I would have said this would have been strong negative correlation, okay? Strong negative correlation. All right. So, before we do this review, we're actually now, before we move on with anything of today's notes, we're going to turn back to where we left off yesterday. So take a look at yesterday's notes. Take a look at yesterday's notes. Take a look at yesterday's notes. Pictures, how did they look? It was these ones. They had 3 at the front. We already took them out, but we're turning to this page. The one that says interpolating and extrapolating. I'll give you the next 10 seconds. Be ready. We're going to fix it. All right. Here's what I want you to do. Before I introduce this topic at all, I personally think that you're going to be able to do the top half without me having to teach it to you. So what I'm going to do is for the next 3 minutes, by yourself, try to do it on your own. Then I'm going to come in and fill the holes. Okay? For the next 3 minutes, try to do it on your own. The only guidance I'm giving you is read the problem, read the question. Afterwards, I will be filling in the holes, okay? 3 minutes, by yourself. Let's go. We have seen this in a different context. So first, I just want to push it to see if you're able to arrive at the conclusion we're all going to, but by yourself. Think about what's being given. Think about what's being given. If you're already trying to answer number one, think about what's being given, okay? Some of you guys are using your calculators, others are not. That's cool, that's fine. Some of you guys noticed something, others did not. That's fine. Already given to us the equation that we're going to be using. What's up?
Regression before.
Manuel over here, he's plugging in things where he noticed something about the equation and he started plugging in on specific spots, strategic spots. JD over here showing a lot of work. Over there on the other side of the classroom, I saw no work for the most part, and that was fine. Different approaches. I already have your check. Okay. So, if you think you've got it, excellent. Just check in on yourself as I'm working with this. If you don't, right now, make sure you're tracking over there at the board, okay? So, they've given me a problem. I read it already. It's about a volcano that it's erupting, okay? They tell me the equation. A lot of us circle that and therefore saved a bunch of time not plugging everything in your calculator and finding the equation. You already have the equation. FYI, the whole thing of us doing this steps was to get the equation. If I already have the equation, there's no need for me to do this, okay? I already have the equation. So, they tell me, okay, using the equation, I'm gonna rewrite it like a lot of us did right here. Y is equal to 12x plus 35. Then I'm gonna read the question. Approximate the duration before a time of 77 minutes. What I'm gonna do is, I always like to underline whatever I'm looking for. I'm looking for the duration, so I'm gonna underline that. The duration, okay? The duration. I'm gonna look at my x and my y axis. The duration, is that the x or the y that I'm looking for? So I'm gonna put it right above it. I'm looking for the x. I'm like, okay. Before a time of 77 minutes. I'm also going to underline the time. Time is 77 minutes. Once again, is that the x or the y? The y, so I'm gonna put the y at the top of that. I'm like, oh. Then I'm going to realize, wait, they've given me one piece of information. Is it the x or the y? Well, the x is the duration, the y is 77 minutes. So which one have they given? The y. Okay, I already have an equation. What do you think I could do, Evelyn? I already have my y is 77. What is a possible solution or something that I could do there?
It's solved. You can plug in the y in the equation.
I agree with you too. Monica over here says something about n solve, which I do agree with. At the time though, right now we are going to still practice it without n solve, right? Still solving the equation. So instead of y, I'm going to write 77 is equal to 12x plus 35. Christopher, I know almost everything in that equation. What is the one thing I don't know in that equation? X. Which just happens to be what they're asking about. So now guide me, Edgar. How can I solve this equation? What can I do? Add 77 on both sides? Subtract 77 now. I could do that. However, I'm trying. The whole purpose is to leave the x by itself, right?
Subtract 35.
Excellent. Subtract 35 on both sides. Those of us with good mental math skills, what's 77 minus 35? I actually.
42.
Is it really?
42, 42.
Okay. So 42 is equal to 12x. I am very close to being done, Edgar. What can I do to both sides? Divide by 12 on both sides. And then I'm not sure if this would be a good one, but 42 divided by 12. Can anybody do that?
3.5.
3.5. Okay, so 3.5. What are my units for x?
Duration.
Duration. So what duration? What are we talking about duration there? If my duration is blank, what are we talking about over here in this problem?
How long the eruption was?
Yeah, and they're not really specifying, but I guess yeah. Over here we're talking about minutes. Over here we're talking about minutes, so we're gonna want to put minutes. Now, knowing how picky control is.